We're going to look at the remainder and factor theorems today. Before we get into polynomials, we are going to just review long division. So if you remember how to do long division, you always want to look at your divisor and you ask yourself, how many times will my divisor go into my first number here? Well, I can't actually take 2 divided by 3, so then I extend it out to 26. Well, I know that 3 will go into 26 8 times, and now I multiply the 8 times the 3, and I get 24, and I put that 24 underneath here. Then I subtract, and I get 2. Bring down my 5, and then we'd start over. Ask yourself, how many times will 3 go into 25? Turns out to be 8 again. Multiply that 8 back, get 24 again, subtract them, and I get 1. Now I don't have any other numbers up here to bring down, so what we would do is we would take this 1 and write it out as a fraction. So I had 1 out of 3 left. So my answer would actually be 88 1/3. The denominator of your remainder always comes from your divisor. Okay, we're going to look at dividing polynomials. And when we do that, there's a couple of things we need to remember. First off, the degree of the remainder is always less than the degree of the divisor. If it's not less than the degree of the divisor, then you're not done dividing. And then the second thing, in order to divide the polynomials, we're going to do synthetic substitution, that same process. So here's our steps for dividing polynomials. First thing we need to do is we need to write it in standard form. Make sure that you're aware of any missing terms. So as I look at our example we have here, this x cubed plus 2x squared minus 6x, I am missing a constant. So I've got to make sure I remember that I need to put my constant in there. Second part says set the divisor equal to 0. Well, here's what I'm dividing by, this x plus 8. So I need to set my x plus 8 equal to 0 and solve it for x, and I get x equals negative 8. This is the number that's going to go outside the synthetic division setup. Then we can go ahead and do our synthetic process. So I set my box up and I bring down my coefficients. Now there's really a 1 in front of my x cubed, so I would have a 1 there. I have 2 for the x squareds. I would have negative 6 for the x. And now remember, I don't have a constant, so I have to fill in a 0 there because I need that place to be held. Then on the outside, I put this negative 8 that we just found. And I perform my synthetic process. So I bring the 1 straight down, take negative 8 times 1 and get negative 8. Add that to 2 and I get negative 6. Take the negative 8 times the negative 6 and I get positive 48. Take that 48 plus 6 and I end up getting 42. Take 42 times that negative 8 and I get negative 336. Add that to the 0 and I get negative 336. Now here's where synthetic division is different than just synthetic substitution. When we do synthetic division, we have to translate our numbers into a new quadratic equation. What we need to do then is take this 1 and it's going to be the leading coefficient. Now if you look at our equation we started with an x cubed. Well, I dropped my degree down by 1. So I would have 1x squared and then I would fill in the rest in order. So minus 6x plus 42, and that leaves this last number as our remainder. Now what I do with my remainder is I add it as negative 336 over my divisor was x plus 8. So this would be my polynomial when I divide those two. Okay, so here's our first practice problem. First thing we need to do is make sure it's in standard form, and I see that I'm missing an x cubed term, so I'll want to make sure I remember to put a 0 in for my x cubed when I set up my synthetic division. Next thing I need to do is I need to take my divisor, set it equal to 0 and solve, so add 5 to both sides and we get x equals 5. This is going to be what's on the outside of my synthetic division box. So when I set up my synthetic division, I bring down my coefficients, so I have 3 for my x to the 4th, 0 for x cubed, negative 5 for x squared, negative 6 for x, and 8 is my constant. Then I put that 5 on the outside, and I go ahead and do my synthetic division process. Bring the 3 down, then take our 5 times our 3 is 15, add that to our 0, and we still have a 15. Then take 5 times 15, that gives us 75. Add that to negative 5, so that gives us a 70. Then take 5 times the 70, and we get 350. Add that to the negative 6, and we get 344. And then take 5 times the 344, and we get 1,720. Add that to the 8, and we get 1,728. Now I need to take these numbers and I need to rewrite my new equation. So the 3 is my leading coefficient. Then I come back up to the top and I look at my degree was x to the 4th, so I drop down 1 degree, so I would be x to the 3rd. And then I just keep filling in the blanks. 15x squared plus 70x plus 344, and that leaves my remainder. So I would have plus 1728 over my divisor, which my divisor was right up here, the x minus 5. Okay, here's another practice one. So go ahead, pause the video, and see what you come up with for this division problem. Alright, when you do your synthetic division, you should have gotten 2, 5, 3, and 0 across the bottom. So our new equation would be 2x squared plus 5x plus 3. Now notice this one turned out to be very, very special. Our remainder turned out to be 0. What that means is that we have found a factor. Because think about, if I asked you what the factors of 8 were, you would tell me it would be 1, 2, 4, and 8. And that's because if I take 8 divided by 1, I get 8, remainder 0. If I take 8 divided by 2, I get 4, remainder 0. If I took 8 divided by 4, I would get 2, remainder 0, and 8 divided by 8 would give you 1, remainder 0. So a factor is when we get a remainder of 0. Well, right here, our remainder was 0, which means that x plus 3 is a factor of our equation. That's going to be critical. So anytime that your remainder is 0, you have found a 0 which can be turned into a factor. What I mean by that is, let's say we have an equation and we know that 3 is a 0 because our remainder turned out to be 0 when we went through the process. Well, if we need to change it into a factor, we have to remember that we started with x equals 3. Well, factors are always set equal to 0, so I would have to subtract 3 and subtract 3. So I would have x minus 3 equals 0. This would be my factor. So factors and zeros are very, very closely related. Okay, here is another practice one. A little bit different here. It says factor as far as possible given that f of 2 is a 0. Then find all the zeros. What this is telling us is that we have a factor. When our 0 is 2, that means we have x equals 2. Well, I'm going to change that into a factor. I'm going to subtract 2 from both sides, and I'm going to end up with x minus 2 equals 0, and that's a factor. So x minus 2 is one of our factors. Now, the way we use this is I know that if I put this 2 on the outside of my synthetic division, I'm going to get a remainder of 0. And what that's going to do for us is it's going to get us a simpler equation. So I'm going to go ahead and set up my synthetic division problem. It's already in standard form. There aren't any missing terms. I'm going to put that 2 out here, and I'm going to divide it down to make it smaller. So bring the 1 straight down. 2 times 1 is 2. Add that to -2 and we get 0. 2 times 0 is 0. Add that to the -9 and then multiply by 2 again. And see how we got our remainder of 0? That fits with what this piece of information was telling us. So now we need to go back and we need to rewrite this equation. So I'm going to have 1x squared because I had to drop the degree of my original by 1. And then I'm going to have plus 0x's minus 9's. Well, that would really just be x squared minus 9. It says then find all the zeros. Well, first we have to factor it as far as possible. So right now, I have an x squared minus 9, and I have this x minus 2 from before. Well, x squared minus 9, I can factor that farther. It's the difference of 2 squares, so it's going to be x plus 3 and x minus 3. That's one of those shortcuts from your flip books. I can't factor those any farther, so my completely factored problem would be the x plus 3, the x minus 3, and then don't forget about this one also. It would be x minus 2. Now, if I multiplied these 3 binomials back together, I would get my original equation here. So here's my completely factored problem. Then it says find all the zeros. Well, I set each of these equal to 0. So I would have x plus 3 equals 0. Solve that one out, and I'm going to get x equals -3. Then I would do x minus 3 equals 0. Solve that out, and I get x equals +3. And then I still have my original one that came from the problem, x equals 2. So this one has 3 zeros. Okay, so here's your 2 problems. Factor the polynomial as far as possible, and I have given you the fact that f of -3 equals 0. So you're asked to factor the polynomial. That means set it up in the parentheses as far as you can.